So I'm going to go through the solutions to this. The first thing I did was went into Stata. I use Stata, and that's what I suggest that you guys to use, because when we do our next unit hypothesis test, that is what we're going to use. It's going to make our lives a lot easier, I think. But for this one, I typed the data set in. In terms of the summary stats, hopefully you got the same thing as I did. Hopefully you all typed our data in. Remember, to get the summary stats, I typed summarize space var1. I got 9 observations. The mean was 2.1555 repeating, and the standard deviation 1.048941.
How did I get 18 observations? I typed in all the data all the way across.
Did you do 0, 1,
Yeah,
1,
not sure.
2.7?
Those weren't commas; those were decimal points.
Okay, that's why.
Yeah, if you type the data in wrong, you're not going to get the same summary stats. In terms of the solutions, this is what I've got. Number one, if you wanted a point estimate, maybe the best we could do is 1.0489. Again, it's, the S is biased for sigma, but that's maybe as well as we can do. In terms of the confidence interval, this is a 90% confidence interval. Hopefully I looked up the chi-squared values correctly. But for both of them, I'm going to take n minus 1, which is 8. Is that right? Yeah. So take 8 times s squared and divide by the 2 chi-squared critical values. I got 15.5073 and 2.7326. Remember, those came off of the 8 degrees of freedom row in our chi-squared table. When I simplify those, I get 0.7534 up to 1.7947. The follow-up question was, is it reasonable to think that sigma is 1? Well, yeah, 1 falls within our confidence interval, so yeah, that's reasonable. So we don't need an MVD there. And because you actually have the data, we can check the assumptions. So SRS, again, I intended to give that to you. I actually changed the problem so it says that now. The big one here is going to be normal population. I didn't tell you that. You don't know. So if you are given a data set, what you can do is look at the QQ plot. So here I said, yeah, I think it might be reasonable based on the QQ plot to think the population is normal. This is what the QQ plot looks like. So in Stata, this is what it looks like. Remember, what we're looking for in a QQ plot that would say, no way this is normal, is some huge systematic curvature. If it's really bowed this way or the other, or an S shape or something like that. I don't see that here. And it's difficult to see, I think, a lot of times when you only have a sample size 8. So a QQ plot's going to do better than a normality test or a histogram or something, but it's tough to make assessments regarding normality when you only have a sample size 8. But based on this, I don't think it's too bad, right? I don't think there's anything that would jump out at you and say, there's no way this is normal. It's not too bad. There's a little bit of curvature there, and not all the points are exactly on the line, but when you deal with random data, that's what you might expect. So yeah, I would say it might be reasonable to think the population is normal. We're not guaranteed that the population is normal, but maybe it's a reasonable assumption to make. Any questions on this one?